Modern enterprise systems generate a massive volume of data, distributed across relational databases, APIs, and cloud platforms. Managing this fragmentation is a core architectural challenge. In a traditional point-to-point architecture, every new system requires a bespoke connection, creating an exponential n-squared scaling problem. Relying on custom-coded microservices to maintain these links is brittle. When logic drifts, pipelines break, generating immense technical debt. Many teams deploy Apache Kafka as a central streaming platform to solve the messaging layer. However, this still leaves a critical ingestion and egress bottleneck at the edges of the network. Data still needs a way in and out. The data engineering team at Royal Research modeled a definitive approach to bypass this exact bottleneck. Their solution relies on implementing a specific integration layer, Kafka Connect. Kafka Connect is a native Apache Kafka framework designed specifically to stream data between the central cluster and external systems. It accomplishes this without requiring engineers to write a single line of custom ETL code. By shifting the architecture from imperative coding to a declarative framework, data teams can scale high-throughput integrations seamlessly. Data sources sit on the left, target syncs on the right, and the Kafka cluster acts as the central hub. Source connectors pull data continuously from upstream systems into Kafka topics. Sync connectors operate in reverse, pushing messages out to downstream targets. The execution of both connector types is entirely configuration-driven. Engineers do not write scripts to move the data. Instead, they configure a JSON file. This single document abstracts the complexity of connection parameters, data formats, and endpoints into simple key-value pairs. Engineers deploy these JSON files to the framework using the Kafka Connect REST API, instantiating the data flow instantly. Enterprise plugins already exist for almost every major platform, including JDBC for relational databases, Elasticsearch for indexing, and AWS S3 for long-term storage. Architects at Royal Research focus strictly on defining what data needs to move. The Connect framework handles the complex mechanics of how it gets there. A highly decoupled data architecture introduces a specific risk, schema drift. Consider a scenario where an upstream database alters a column type or drops a field without notifying downstream consumers. An integer becomes a string midstream. When that malformed packet hits the target data warehouse, it causes critical ingestion failures and corrupts the existing datasets. Kafka Connect defends against this using the Confluent Schema Registry. The registry acts as a centralized repository for data contracts. It defines strict compatibility rules across all connected platforms. Pulled by a source connector, a record doesn't go straight to the topic. It is first routed to the schema registry and checked against the established contract. If compatible, the record proceeds. If it violates the rules, it is blocked and flagged. Enforcing this schema consistency at the point of ingestion eliminates silent data corruption and ensures long-term system interoperability. In distributed enterprise systems, firmware fails and processes crash. This distributed architecture is designed specifically to survive node failures. The main JVM processes, called workers, contain individual threads called tasks. These tasks handle the physical copying of data from source to sink. To handle increased load, administrators spin up additional worker nodes to scale horizontally. However, if a worker node experiences a critical failure and goes offline, the tasks inside it freeze. The cluster immediately detects the failure and triggers an automatic rebalancing protocol. It intelligently redistributes the orphan tasks to the remaining healthy workers, keeping the pipeline active. A midstream crash introduces the risk of data duplication or loss. Kafka Connect prevents this by systematically tracking and committing data offsets for every single record it processes. Reassigned tasks read these saved offsets, resuming ingestion exactly where the failed node left off. This fault-tolerant architecture guarantees continuous, reliable data streaming without requiring manual engineering intervention. Looking at a fully realized enterprise data topology designed by Royal Research, the macro architecture operates through several concurrent pipelines. In one pipeline, IoT device telemetry is ingested continuously into the central cluster via HTTP source connectors. Simultaneously, operational logs from distributed microservices are aggregated and pushed into Elasticsearch via sync connectors. And in a third pipeline, relational database records stream directly into a centralized data warehouse for business analytics. All of these disparate integrations execute on the exact same underlying Kafka Connect infrastructure, governed entirely by simple JSON files. Administrators oversee this global throughput and track connector health using monitoring interfaces like the Confluent Control Center. Organizations replace brittle, bespoke ETL scripts with a standardized, horizontally scalable integration layer. As real-time data processing becomes mandatory, Kafka Connect provides the declarative, fault-tolerant highway required to architect the modern enterprise.